So right now we have discussed a lot of things related to probability. I think if you are from a stats or math background, you must have already already know this type of things, especially Bayes theorem and other type of things like conditional probability and total probability. So all these things you can now start solving a lot of questions, and like these particularly questions you can solve. And the thing is that there is some requirement of permutation and combination, sometimes set theory, and later we will see that when we will study the binomial theorem that binomial distribution. In binomial distribution, you're required to learn more about binomial theorem, and later in the continuous type of distribution, integration and differentiation is the most common. So obviously these are all from the maths topic that are coming into the statistics, and as good as you can do the integration, you can solve complex probability type of questions also. But things that we have covered some syllabus, and time to time I'll be just putting some more questions. But things that you have to do some practice from your side also. And especially I study I visited at particularly Gupta Kapoor book, and I found that there are a lot of good questions in that particular book. So there are a lot of practice questions related to permutation, combination, set theory, and all the different types of probabilities that you can find. And there's something called geometric probability in that particular book. So geometric probability is not something that is going to be asked. And but if you just want to advance your level, just you can practice geometric probability also. But this thing will be not, I mean, so these are just most complicated thing, and these things will not be part of your normal question. So like this question, you can see that out of the telephones, 15 telephones are received at service center. Five are mobile, six are cordless, and four are wired. These 15 phones are randomly numbered from one to five. So you don't know like which of the mobile is number from which number, and order in which they are serviced. Which of the following statement is are correct? Okay, so this is also multiple correct questions. So you need to examine all the options one by one to find out which of the following options are correct. So in this case, it's not like too much complicated question, but thing is that just you need to solve this option by option. The first thing is the probability that among the first three serviced, first and third are mobile, and the second one is not. So let's say these are the numbers 1 to 15, and is asking about first out of first three, the first and third are the mobile. Okay, first and third are the mobile. So let's say first one is the mobile. So out of five mobile, you have just need to choose one. The five C1, which is obviously five divided by 15, into second one is not a mobile. So second one is not mobile, then it can be either cordless or wire. So out of 10 choices, you can choose anyone. So it's 10 by, and now obviously 14 left. And the next one is also a mobile. So third one, now we have just only four mobile, 4 upon 13. Okay. So this is the probability that uh, first is serviced, the first and third are mobile, and second one is not. So similarly, you can just calculate obviously all the options, check and which one is correct or which one is not. Now the probability the first four serviced are all the wired phone is 15. It's writing this particular thing. So you can just check what is going to the probability of this particular thing by just calculating the answer. And 1 minute. So first four serviced are all the wired phones. So out of four wired phone, if you means obviously the first will be 4 upon 15, then 3 upon 14, then 2 upon 13, and then 1 upon 12. And you can just check if the same thing is telling this one. So 15 C4 means 15 factorial upon 11 factorial into 4 factorial. Okay, and if you just break this thing, you will get here 15 into 14 into 13 into 12. 11 factorial will be cancelled, and 4 into 3 into 2 into 1. And if you just take 1 by this particular thing, you will get this particularly same thing, or the same thing. So that's why this both the things are same. So this option will also be correct. Similarly, you need to check for all the options also. So like some concept of probability is being utilized to construct multiple correct questions, and when the questions will be rather difficult, you can solve like this way. So this is also questions of probability, especially for the from the gamma distribution, and it's not so complicated questions, because if you just understand what gamma distribution, and especially the gamma integral, means how to do the obviously the integral gamma function, and you can solve these type of questions, because obviously mean, median, mode, and given, and thus you need to apply the gamma integral and gamma function. So are you aware about the gamma function or gamma integral? Anyone? Yeah. Means the integral will be same, but like it has been just what you can say, just crafted in some form of distribution, and but the same properties of gamma distribution, gamma function will be applicable. So I will just explain these things while we discuss all the continuous and discrete distribution. So yeah, that property will be useful in solving this type of integration. So there is a beta distribution, and then there is a gamma distribution, and both are based on the beta integral and gamma integral. So that will be useful there. More questions you can see, like when you just visit other and see how what are the other probability types questions that is being asked. Okay, so this is also probability type questions that we will be able to solve after today's class. So this is from a continuous distribution, and we'll be able to solve after today's class. Okay, so a lot of discussion. So let's now start with the today's lecture. So I told you, especially I'll be discussing about the random variable. Okay, so there has been a lot of definition about the random variables, especially if you wrote any study any advanced probability course in your college, or obviously in your masters. You will be learning more about the different types of definitions involved in the random variable. But the simple thing is that random variable is a mapping that associate a real number with the each element in the sample space. So it's just a mapping. So let's say you are tossing a coin, and obviously the outcome is head and tail, and you are trying to find a random variable. You are just trying to define a random variable, which is, it means number of head. Okay, number of head. So in that particularly case, h correspond to 1 and tail correspond to 0, because this particularly outcome is associated with real number, and that mapping tells that h means there is one head, and tail means there is no head. If it has been a two tossing of coin, then in that particularly case, the thing would be different. In that case, if you want y to be your what you can say, just number of 8, then in that case st correspond to 1, it is correspond to 2, this correspond to 1, and this correspond to 0. So this is just random variable. So here y is the random variable, which is number of head when you are tossing two coin, and this is just a mapping from the sample space to a real number. So here the real number is 1, here the real number is 2, then is 1 and 0. So based on this type of random variable, means based on these type of things, random variable can be of two types. Like we will see, there is a discrete random variable, there is a continuous random variable. Because real number, like it can be integer, or obviously it can be other some number from in within the some interval. So we will see like how these things are coming to the picture, and how the things are with the continuous and discrete random variable. So for one more typical example, just we can see that let's say there are there two balls are drawn in succession without replacement in from an urn containing four red balls and three black balls. So there is an urn, and it contains four red ball and three black ball, and we're just drawing two balls out of this particular thing. Okay. So in this case, let y be the random variable, which is number of red balls. Then values of y of random variable capital Y is given y. So like what are the all possibilities that can be given? So either it can be since red and black ball are within the bag. So either it can be two red ball, either it can be one red ball and one black ball, either it can be a black ball and a red ball, and then it can be two black balls. Okay. So in that particular case, if y is defining the number of red balls, then y will be either 2, 1, 1, or 0. So this is what y can take the values when we are just defining this particular thing in a sample space. Because from our experiment, this is what we are defining. So if, at later stage you'll see, like maybe what we are interested in finding, okay, what is the probability that y is equal to 1. So y is equal to 1 means there is only one red balls in this particular thing, and obviously this thing correspond to these two event. Okay, so these 2 point in the sample space, which is rb and br. So in that case, we know that the size of our sample space is 4, and we have just two sample point from in that particular event. So this will be 2 by 4. Okay, you may ask me what is the y probability of y is equal to zero. So same thing, just see ki y is equal to zero correspond to this particular thing. So we have just one sample point, so it will be one by four. Okay, so this way you can just read the means find the probability of discrete sample space also. But we'll just see everything in the detail in the just we are coming through. Okay, so I told ki, like we told ki this particular thing, random variable can is the associating a real number with the each element in the sample space. Obviously, in this particular regard, we actually define our sample space of two types. First one is discrete, and second one is the continuous sample space. There are some hybrid sample space also. Obviously, in the advanced probability course, we are being taught. Some point maybe lies in the discrete region, then some point may lie in the continuous region. Okay, so those type of distributions are also there, but just for now, just let's for simplicity, just focus now on there are two types of sample space: discrete sample space and continuous sample space. So let's say your possible outcome is countable. So now here you can see that you can count your sample space. So there is only four possible outcome. So means any set of possible outcome is countable, then that particular sample space is called discrete sample space. But if you can't means if that particular thing is uncountable, we'll see like how this continuous sample space and continuous distributions are defined. So continuous distribution means there will be some, like we just may just say that okay, your particularly sample space lies between this particular region. Okay, one to two or something like that. So there will be some reason particularly given. You will not be able to what you can say. You will not be able to associate that particular thing with countable numbers. Okay, so continuous sample space simply means you just can't count the point in the sample space, and on discrete sample space you just these points are countable. Maybe you're tossing a head, you are tossing a coin, or tossing a die, or maybe like in binomial distribution also. Let's say you are just trying to find something for one, two, three values. Okay, and we're defining some obviously some probability function. So in that case, these things will be countable because your sample space is just 3 point in the obviously in the integer. So these type of things are there. So simple thing, random variable is just a mapping of a real number for each element in the sample space. It can be two types: discrete and continuous. Discrete means the possible outcome will be countable, and in continuous you can't. These are not uncountable. Possible outcomes are uncountable. Now we will start from discrete probabilities, discrete sample space. So like on the basis of discrete sample space, when your sample space is discrete, we can define a discrete probability distribution. So like probability distributions means I was already told every element is being specified with a real number. So like let's say x is equal to zero. We are let's say x is equal to 0, 1, 2 are the our real numbers that is associating with this probability. Like here you can say. So you are interested in seeing what is the distribution. Distributions in general terms to understand what will be the distribution of this probability. Okay, so for x is equal to 1, you will get some different probability. X is equal to 1, you get some different probability, and x is equal to 2, you get some different probability. So based on these three values and based on this probability, based on that is depend on three values, we actually construct a probability distribution. But every probability distributions, whether it's a discrete or continuous, actually have some properties. And just we start from the discrete probability distributions and then we move to the continuous distribution. So discrete distribution tells you that a set of ordered pairs x and fx. So x means obviously x is simply the point like zero, or fx means fx is your what is the probability at x is equal to that particular thing. So it's just a simple probability function. Fx is called a probability mass function. Okay. So in discrete case, the probability distribution function is called probability mass function, and this particularly in the continuous space it is called probability density function. So this particular thing is defined as is a probability function PMF if for each possible outcome x, fx greater than equal to 0, summation of fx is equal to 1, and in that particular case fpx is equal to is defined as fa. So let's just understand each thing step by step. So it means that if say someone is saying that okay, this particularly fx or this particular gx, anything you suppose, this particularly fx is your probability mass function. So you have to keep in mind that whatever you are value putting up, so let's say it is defined for x is equal to 3, 5, and 7. So if you put x f3, you will get a number obviously, and that will be greater than 0. That will be greater than 0. If you put f5 also, you will get a number which is greater than 0. And f7 also, it will be number greater than 0. So this is the first properties of the probability mass function. Okay, you will be given a function, obviously, or it will be defined for a discrete sample space. And when you will put all those points one by one, you will get a number, or your number which will be greater than zero. Okay, if it's giving some negative value, it will not be a probability mass function. Okay, so let's say I define a probability mass function fx is equal to minus 2x. Okay, and I say that okay, this is defined for x is equal to 0, then minus 1 and 1. Okay, so if you just put it 0 here, you will just get the 0. So obviously that is fine because it is equal to 0. The second thing is that if you just put it 1 here, you will get a negative value, which is not taken into consideration, because negative things is not allowed here. And if you take minus 1, you will get a positive value. So these things are there. Okay, so this is the first properties that you need to, if you just, anyone is saying that this particular function is your probability mass function, then this is the first property you need to think of. Now the second property is that when you put all the particularly values of x and you sum all the particular values of fx, you will get a sum of 1. Okay, so let's say we defined fx is equal to x by 2. Okay, and here I just say that okay, this probability is defined for x is equal to 1, and what you can just say more. Okay, so in that particularly case, if you just okay, just let me think of some other. Okay, so now just let me give you some typical example like that we saw above, and just see how this particular thing is happening. Okay, so to find this particular thing, just let's see this example that we discussed above. Okay, let's say we are defining a probability function fx. Fx is equal to 1 by 2 when x is equal to what I can say, x is equal to 1, and fx is equal to uh, 1 by 4 when x is equal to 0 or 2. Okay, so in this particularly case, we can see that we are actually defining this particular sample space. Okay, we are defining this particularly sample space into probability. So you can see that if fx is equal to 1, you will have the probability of 1 by 2, and if fx is equal to 2 or 0, you will have probability of 1 by 4. So we can define this particular probability this way. Okay, now you have to check if this particularly fx is your probability mass function or not. Simple thing is that first step you need to check whether the fx for each point is greater than 0 or not. So if you put f1, okay, you will get 1 by 2 which is greater than 0. If you put f0, you will get 1 by 4 which is greater than 0, and you will put 2 also, you will get 1 by 4 which is greater than 0. So first condition is satisfied. Okay, the second condition is that you have to check for the summation criteria. Summation means put each values of x. So it means this particular things relate to this means f1, sorry, f0 plus f1 plus f2 should be 1. Okay, it should be 1. So f0 is equal to 1 by 4, f1 is equal to 1 by 4, and 1 by 4, sorry, 1 by 2, and f 2 is equal to 1 by 4. Obviously these particular things add to 1. So exactly fx is a your probability mass function. And this third criteria is used to find out any specific probability. So let's say in this particular case you want to find, okay, these things actually says that okay, this is a probability mass function. Then what is the probability that x is equal to 3? Okay, x is equal to 3. So x is equal to 3. Actually, we actually write here that otherwise this particular thing is 0, if x is 0. Okay, so obviously this particular x is equal to 3 is not in this particular domain. This only 1 and 0, 1 0 and 2, and for otherwise this particular whole value of x is 0, so this probability will be 0. If one knows, okay, what is the probability that x is equal to 1, in that particular case you know that if x is equal to 1, this fx is treated as probability function. So probability that x is equal to 1 is 1 by 2. Okay, so this way you can just use probability mass function to calculate probabilities and actually check whether this particular thing is a probability mass function or not. So, guys, did you understand this thing, or do you have any question? Okay, so just typically let's understand some more examples of a probability mass function. So let's say obviously I described this example now. So just let's see some formal thing. So let's say a fair coin is tossed twice. Let x be the number of heads that are observed. Construct the probability distribution of A. Okay, so in this case it is talking about probability mass function of A. Okay, so obviously the possible values that x can take is either 0, 1, 2. So if you're tossing two coin. Either it can have zero head or one head or two head. Each of these number correspond to an event in the sample space. So obviously these are the sample space we have. We already know that, and each of these sample point will be actually having some number associated with that. So if we're talking about x is equal to zero, so obviously this particular thing is there. If we're talking about x is equal to one, this particular thing is there, and if x is equal to this particular thing is there. Obviously, x is equal to 0 means if I'm trying to find probability that x is equal to x, then in this particular case, 0 just point to a single entity, or it's a single point in the sample space. So our sample space size is 4, and x is equal to 0 correspond to single point, so it will be 1 by 4. Obviously, this x is equal to 1 correspond to 2 points, so it will have 1 by 4 plus 1 by 4. Obviously, considered 1 by 2. And this particular thing is that x is equal to 2 is head. So this also corresponds to just a single point, so size is 1 by 4. Okay, so this is the how you construct a probability distribution, probability mass function of any given situation. You can also see that he obviously so that this particular thing adds up together to summation of one. Okay, so fx simply means that fx simply in discrete probability distribution means that we will do that x is equal to small x. A small x means the values that the x will be taking. Okay, so these are the values that x is taking, and capital X is the random variable. So random variable can take some value. So we will define these values by small x. Okay, so fx simply means probability that capital X is equal to small x, and this particular thing is the numbers considered 0, 1, 2 here we are looking at, and we can actually construct a probability distribution based on it. Okay, so second question is that find the probability that at least one head is observed. So in the same questions, we have to find a probability that x is greater than equal to 1. So x is greater than equal to 1 means x is equal to 1 and x is equal to 2. So it's a union of two events. Probability that x is equal to 1 and x is equal to 2. This is a union of two events. So either x can be 1 or either x can be 2. You know that if x is equal to 1 and x is equal to 2, this is a mutually exclusive event. Why? Because x cannot be 1 and 2 simultaneously. Okay, x cannot be 1 and 2 simultaneously. This is not possible. Okay, because we're just tossing two coin together. What? How can it happen that you just get one head also and two means obviously in the two coins that you are observing, you get one head also and two head also. So this is not possible. So that's why these type of events are mutually exclusive event, and just you need to if you just break this probability into simple thing, and here you also add probability minus that x is equal to 1 intersection x is equal to 2. This is by default 0. Okay, so this is not counted. So in that case, what is this probability x is greater than equal to 1? Obviously, x greater than equal to 1 is either x can be 1 or either x can be 2. So x is equal to 1, x is equal to 2, and union sign, and then you can break them into using the summation of probability. But obviously, this thing is 0, intersection thing is 0. So probability that x is equal to 1, and you get that probability of x is equal to 1 is 1 by 2. So you write 1 by 2, and probability x is equal to 2 is 1 by 4. So probability mass function actually gives you the probability of that random variable at particularly specific point. Okay, like if you want to find the probability of x is equal to 1, just see that corresponding to x is equal to 1 in the probability distribution, what is the particular probability. So this is why probability distribution function means. And particularly if you just add this thing, you get the obviously the probability of required that at least at least one head is observed. Actually, you can represent this probability distribution using the graphical representation also. Graphical representation means ki, okay, x is equal to 0, what is the probability? So 0.25, just to make a single bar here. Okay, x is equal to 1, it's a 0.5, and for x is equal to 2, it's again 0.25. So this is called a probability distribution of tossing of two fair coin. Okay, so you can actually illustrate these things graphically also. So, guys, any problem with this particular thing? Hello, your voice is not clear. Okay, so was someone speaking because I could not hear them? Okay, so when you will go to this Gupta Kapoor book, you will find a lot of different type of questions, and like basic questions has been given a lot. So I just advise you to practice some basic questions. Like in discrete distribution also, tossing two die dice, and then there's a lot of things required to find the probability, like a lot of probabilities have been involved. So like practicing these simple questions actually allow you to understand like how the things are going, and how the things are being calculated one by one. And obviously I'll bring some more examples in the next class, but just we are introducing a random variable. But simple thing, just most simple thing is that you'd have to this is practice a lot of basic questions also, because like obviously you see that this particularly probability, these are not too advanced questions, but these are just a basic question. And when you see this particularly obviously this where it's went gamma distribution question. This is also not it's a long question, but thing is just based on a probability density function of a gamma distribution, and everything is given. So in this, using this particular thing, you can calculate the alpha and beta, and then you can use the in gamma integral properties to find all these things. Okay, so these things are not too difficult, but things that these are just state basic from the PDA, PMF, and obviously sometimes but not always, sometimes go application based questions can be asked like this one. And especially like earlier in the beginning when we used to appear for the CMI, actually they actually ask a lot of different questions. Okay, so here you can see that there is some questions given ki if Z is a continuous random variable which follows normal distribution with mean 0 and standard deviation 1, then this particular thing is given. So this information is given to you. Hello. Okay, now can you hear me? I think obviously network issue is there from my side. Okay. Okay, no problem. I'm just repeating it again. I was telling ki means these type of questions is asked. So I was telling uh, especially like these type of questions ki jet here continue means, so I told ki questions will be from PDF, PMF, and obviously sometime application based questions can be asked. So things will not go beyond than that. You can just see that. So this is questions that this Z is a continuous random variable which for normal distribution. So it's a standard normal distribution 0 1, and its format is given like what will the PDF. So these type of things are given. So it will not require you to like no remember a lot of things. You just need to think a lot of things, and some particular values of random distribution is also given. And it's asking about ki x plus obviously mean plus sigma z follow normal distribution mean 0 and standard deviation 1. The length of life of an instrument, obviously it's application based question, produced by a machine is a normal distribution with a mean 24 months and standard deviation 2 months. The probability that instrument produced by this machine will be less than 18 months. So basically it's asking the probability that x less than equal to 18 months. Okay, so we'll see like when you just see the random normal distribution, we'll see like how we can solve this type of questions, and using the particular this type of variables. So obviously simple. If you don't know also the random variable, just understand how the continuous distribution work. You can easily solve these three questions, and these are based on the same particular type of question. So these type of questions will be their application based question, and so we'll discuss these things. Okay, guys, have you solved these particular questions or not? This question, the time zone question. I think it's from the 2018 paper. Have anyone solved this? Like these are the reasoning type of questions. So reasoning you have to do by yourself. Obviously, maybe you can just think like how you can solve the reasoning type of questions, because the reasoning is not taught anywhere. Just you need to think and you can do that question. So after the class, you will not try this question. Just try this particular question, because these things actually require some thinking skill, and just try this thing out. Okay, this particular question. Okay, so after the, I think my voice is clear now. Okay, right? Okay, so just I can say that I have network issue, because like at my home I just using mobile connectivity, but okay. So means right now I'm audible, right? Okay, so using this probability distribution function, we can just go one more level, which is called cumulative distribution function. So cumulative distribution function means you are trying to what do you say? No, like let's say First of all, cumulative distribution function is defined as this way. So it is denoted by the capital Fx. It's not by the small fx, because in probability and random variable, a small fx is means a small f, a small g, a small h. These things are actually used for denoting probability mass function or probability density function. But capital fx are actually used for cumulative distribution function. So simple cumulative distribution functions definition is probability at x less than equal to x. Okay, so if you are trying to find f0, so it means probability at x is less than equal to 0. Okay. If we're trying to find f1, it means probability at x less than equal to 1. Obviously, it means that if your x is equal to 0, 1, 2, so this thing actually means probability at x is equal to 0 and probability at x is equal to 1. Okay. So these things are with a cumulative distribution function. If I talk more about some examples of the cumulative distribution function, a simple example, just let us go above and just see this thing, like how we can find a probability density function of distribution function of this tossing a coin. Okay, so obviously we know that tossing a coin actually result into the four sample space, and actually we uh, uh, know their probability distribution. Okay, so probability distribution we already know, and using those we have to find the uh, probability density function. So this is 1 by 4, this is 1 by 2, and this is 1 by 4. So obviously fx is also a table, will be also a table. And first of all, just we need to find what is f0, because x takes 0, 1, 2. If x0 is probability takes x less than equal to 0, which is just 0 because there is no any value less than 0. So this is 1 by 4. Okay, f1 means probability that x is less than equal to 1. In that case, we have for 0 and for 1. So we just add 1 by 4 plus 1 by 2, which is 3 by 4. And f2 this probability that x less than equal to 2. Obviously, this is going to be 1 by 4 plus 1 by 2 plus 1 by 4. This is going to be 1. So in this way, you can construct a probability density function, which is just what you can say. This is fx, and this is x is equal to 0, 1, 2, and this will be your 1 by 4, your 3 by 4, and this is 1. So this is called a what do you say? This is called probability distribution function. Okay, this is just a cumulative distribution function or distribution function. So this is generally termed as CDF, and probability density function is PDF, or it's either PDF or PMF, probability mass function. So this is for discrete and this is for continuous. Okay, so CDF is cumulative distribution function. Simply just uh, defined as probability at x less than equal to x, and you can just find everything this way. Okay, so do you have any problem understanding cumulative distribution function? After cumulative distribution function, we actually can see a lot of examples. So like whenever you are practicing, if you just know these things, it's all right, because whenever you are practicing, you have to like I told you, CMI actually don't ask a lot of difficult questions, memory based questions, or questions that is actually required you to use a lot of concept. But thing is that using the simple concept, a lot of things will be there, and you have to apply those skills. Sometimes questions may appear so long because you just think that okay, these questions are so long, but obviously these things are, if just you know the basic, you can actually solve those questions easily. Obviously, now at this point of time, just let's discuss another example. So the example is x have the following probability distribution. Okay, so x is equal to 0, means at point 0, 1, 2, 3, 4, 5, 6, 7, there are the different probabilities that has been defined. So you have some specific given questions given to that. Okay, the first question is find k. Okay, so do you have any idea like how we'll find k, which by using the probability of obviously using the property of probability density function, how we'll find the k? Anyone? Because anyone, do you have any idea about like how we are going to find k? Yeah, yeah. So sigma probability at x is equal to small x is equal to 1. So just you need to add all this probability and solve for k, because k is going to be a quadratic equation, and then you can get the value of k. Okay, so this will be 3 to 5 to 7, 8, 9, 1, 9, 9, k plus 7 to 9 110 10k square is equal to 1. Okay, right? So in this particular case, 10k square uh, plus 9k is equal to minus 1 is equal to 0, and you can solve for k, and obviously you can solve for k and just find the result. So this thing will be actually so, like you will get two values of k. So one k will be negative, and one k will be 1/10. But you know that if you just put k is equal to 1/10 here, you will get that you will have the probability of negative for one. So this particular thing cannot be possible because any probability cannot be negative. That's why you will not choose k is equal to -1. This thing will not choose. You will choose k is equal to 1/10. Okay. So after this, you have the probability mass function of each and everything. Okay, so if you just put here 1/10, you'll get the probability mass function of 1, and you'll get the probability mass function of for 2, 3, 4, 5, 6, and 7. So using this particular thing, solving the quadratic equation, you get the k. Okay, now at this point of time, you have some more different questions that is actually given to you and that you need to find out. So the second question is, what is probability that x is less than 6? Okay, so x is less than 6 means these things actually translate to different thing, and this means that either x is equal to 0 or 1 or 2 or 3 or 4 or 5. Okay, or you can also think it the other way. Probability that x less than 6, if you just try to what you can say, just like there is something I told is discussed with the probability of A plus probability of A complement is equal to 1. Okay. So this particular thing can be used here. We are giving that A is equal to x less than 6. So A complement will be obviously x greater than equal to 6. Okay. So if A is x less than 6, so A complement is equal to x greater than equal to 6, because these two things are mutually disjoint event. Okay. So are you getting it? Why, how we can translate this into this way? Okay, so indeed, this particular case, x less than 6 is transformed to x greater than equal to 6, and this sum of this both probability is equal to 1. So this will be 1 minus probability of x greater than equal to 6. So in this case, x greater than equal to 6 means x equal to 6 and 7. So here you have to calculate probability for only two things, 6 or 7. But here you have to calculate probability for 0, 1, 2, 3, 4, 5. So in this way, you can just ease your calculation speed. Just 1 minus in the obviously in the calculation field is 2 into 1 by 10 k square, uh, obviously plus 7 by 10 k square plus 1 by 10. Okay, so these two particular thing we will add and just we get and divide and minus by do minus 1 1 minus particular thing, and we'll get the probability of x greater x less than equal to 6. So means just are you able to get it, like how we are doing this particular thing using the concept of x greater than equal to 6, and why we are doing this? Anyone? Okay, so the question is, you have to find a probability of x less than equal to 6. Okay, so the one way, just take all the value. I think some noise is coming from your side. So x either can be 0, 1, 2, 3, or 4 or 5. So just you pick up all those point, and what you do, you find probability of x is equal to 0 plus probability of x is equal to 1, because we know that we can use this technique to find all the probability, and all dot probability of x is equal to 5. But the other way can be just use this particular thing x greater than equal to 6, because I told you if there are two events A and A complement, obviously if A is the event, then probability that A and probability plus probability of A complement, this is together 1. So if you suppose that A is equal to x less than 6, then in that case A complement will be x greater than equal to 6. So we can use this particular formula to find the probability of A. So in that case, probability of A is equal to 1 minus probability of A complement, which is 1 minus probability of x greater than equal to 6. And for get x greater than equal to 6, you just need to calculate two values. for x6 and x7. So that's how you can easily calculate this probability. So is this thing clear? Like, do you understand how why this thing is happening? Yeah. Okay. And like obviously this x greater than equal to 6 calculate the same way. X 0 and x between 5. So you can see that here, here there is no sign of equal to with this less than sign. Okay. It's just purely x between 0 and 5. So here it means that x will be either 1, 2, 3, and 4. Okay. So you just need to find all this probability. If it had been x greater than equal to 0 and less than 5, then you need to take x is equal to 0 also. Okay. And if it would have been only x, obviously x greater than 0, but x less than equal to 5, then exclude the 0 and 4 and 5 also. Okay. The main thing is that you have to see the sign here. What is the sign, particular sign? Is it less than or less than equal to, or what is the sign here? Okay. Because using this particular thing, you can find the required probability. And same way, you can just find also the distribution function of it. Just now we have all the probability. Just keep adding everything one by one, and just we will get the probability distribution function of x also. Okay. So is this thing clear with everyone? Like, means if a distribution is given, can you like at least calculate the probabilities, distribution function, and obviously some complex probability like this type of things if involved? Can you do this type of things or not? Okay, so at this point of time, we can define some other definition. So, like when you are considering any random variable, there is actually a lot of quantities associated with the random variable. So, there is a mean of the random variable, there is a variance, there is standard deviation. Standard deviation is calculated from the variance, and there is other thing also like there can be median, there can be mode, or different type of variables. Okay, so for now, just let us focus on mean and variance, and let's see how we can calculate mean and variance, and then we'll also focus on these type of things as we proceed through the course. So if we are exclusively talking about a discrete distribution, and like let me just discuss it for you with the discrete distribution, and when you'll see the continuous distribution, we'll actually see how you can just so means just translate the definition of continuous distribution of any particularly quantities into a discrete random variable. Okay, so things that a mean of a discrete random variable is defined as expectation of x. So it is termed as expectation of x, expectation of x, expected value of x or expectation of x. And is this is written as capital E, and in the bracket you write x, and in that case you write this definition as summation over all x, x into probability rate x is equal to a small x. Okay, so this particular thing is called expectation of x, and this is also denoted by mean, called as mean. This is also called as mean, and this is also denoted by mu. Okay, so this is the particular definition of expectation of x. Simply just summation x into probability rate x is equal to x. So let's say you are tossing two coin. Okay, you are tossing two coin, and obviously we know that in that particular case the probability and this thing calculates translated to 0, 1, 2, and you have 1 by 4, 1 by 2, and 1 by 4. So let's say we are trying to find the mean of this particular random variable x, which is a number of head. H is a number of head, and we are trying to find the its mean. So expectation of x is simply equal to what? Summation over all x. Summation over all x means for 0, 1, 2, whatever the x is, and just calculate this particular thing and sum or add everything. So this means for x is equal to 0, x is equal to 0. So this no need to give summation. So x is equal to 0, 0 into probability rate x is equal to x. It means 0 into 1 by 4 plus uh, then after 0 we have 1 in the x, so 1 into 1 by 2 plus, then after 1 we have 2, so 2 into 1 by 4. So if you just you have just calculated this particular thing by multiplying this both quantity x and px, and then you are adding all those things. So this will be obviously equal to 0, this is equal to 1 by 2, and this is also equal to 1 by 2. So this mean here is the 1. 1 is your mean. So this is how we calculate expected values. If any random variable x is given, you can just find the, if it's a discrete, if you obviously can find the expected value of x or mean, or what you can say expectation of x, everything you can say anything, and it's denoted by mu. Mu means mean. So this is the universal symbol of mean, and often you will find this type of thing. So this is denoted by sigma means summation over all x, summation over all x, x into probability of x equal to x. Okay. So I think this thing is also clear with everyone. At this point of time you can also translate this thing into means obviously you can use a discrete random variable to find out what is do you mean by variance. Okay, so variance means variance, like if you just see in the terms of how you can find is using the random variable definition. But in general, variance means, like let's say you have some data. Okay, so every data will have some mean. Okay, every data will have some mean, and it will have some variance. Okay, so variance is the measurement of spread, like how much your data is spread across the values. Okay, so this is the general intuition of mean and variance. And what the overall thing is, every random variable has some mean and variance associated with that. And like I told, I so with this example, give this particular thing, this random variable, continuous random variable, actually, it's given it, it has a mean zero, standard deviation zero. So a standard normal distribution have a generalized function. So this is a generalized formula of PDF of a standard normal distribution. But you need means in order to find the details, you just need to know what is the mean and variance, because these distributions are characterized by their mean and variance. So if you just anyone tells you what is the mean, what is the standard deviation, you just know that this is talking about obviously the normal distribution, standard normal distribution. In binomial theorem also we will have some mean, some variance. So this part will be actually going to be with us for as long as we are studying probability or random variable or anything else associated. Maybe we are studying about the distribution also. So these things will be there always. Now, at this point of time, expectation variance of x is defined as expectation of x square minus expectation of x ka whole square. So this is just the mean. So this is just the mu ka square. So you will just find the mean and do the square. And this particularly thing is you need to calculate it. Okay, let me just tell you one generalized formula for finding this expectation. So, expected value of any x to the power r in the discrete distribution is equal to summation over all x to the power r into probability that x is equal to x. Okay. So what this thing means, just let me. So let's say you want to find the probability x square. Okay, so r is equal to 2. So in this case, in this particular coin, tossing a head wala case, in this particular case, tossing two head. Okay. So if you need to find this particular thing, it means that take all the values x, square them, and then multiply with their probabilities, and then sum over all the x. Okay. So this means for x is equal to 0, this is 0 k square into 1 by 4. For 1 means 1 k square, which is 1 also, into 1 by 2. And for 2 means 2 k square, which is 4 into 1 by 4. So this actually cancel to 1, and this actually cancel to 0. So you have 1 by 2 plus 1, which is equal to 3 by 2. Okay, so this is how we calculate. So if you want to calculate the x to the power 3, expected value of x cube, you can also do that. Just keep here power 3 for every values, and just multiply by the probabilities, and you can do that particular thing. Okay, so simple thing, if you want to calculate the variance, just find this thing separately, and this then you have calculated the mean and square the mean, and just do this simple calculation, you can get the variance of x. And variance of x is simply written as I have written this particular thing as this way, the way I told you, and this particular thing as mu, because it's a mu square. You will easily get the variance of x. Simple thing, just the simple thing. Just find this quantity separately, and find this quantity separately, and then find the mean. So here you can see that expectation of x squared is 3 by 2, and we have mean our mean as 1. Okay, so this expected value is yeah, 3 by 2, and our mean was in that particular case was 1, right? So we can just find this particular thing, and our variance will be 1 by 2. Okay, so this way you can find the mean and variance of any discrete random variable. Just find this particular quantity, you will give it as a mean, and find this particular quantity separately, and then this quantity separately, and this do this calculation, and you will get the variance of x. So just at this point of time, just let me just write this particular thing very clearly. So this is, this is just let me remove this. So these two things are different actually. Just don't understand it same thing. It's the expectation of x square minus expectation of x a whole square. So here you are finding expected value of x square only, and here you are finding the expected value of x first, Okay, and whatever that value is, you are squaring this particular thing. Okay, so these two things are different. Just don't think that these two things are same. Here you are just finding the expected value of x square, and you are just finding the expected value first, and then you are squaring this particular value. So this is the mean and variance of a discrete random number. This is how you calculate it. Okay, same way you can find the mean and standard distribution of this particular distribution also. This distribution means you have k given, means you have to find first k, then mean and variance, and then you can find the CDF and draw its graph. Okay, so these questions you can do it by yourself. Okay, so graph of CDF, how it's look like. Okay, so we find some CDF, right? Okay, so uh, okay, so in above case, we find some distribution function, and we actually had for the, I think for uh, tossing two coin, we have fx is equal to 1/4, for x is equal to 0, and x less than equal to 0, and this will be 3 by 4 for x less than equal to 1, and this is equal to 1 for x less than equal to 2. Okay, so you can actually convert this particular thing into graph also, so this actually looks like a stepwise function. Okay, so if you just remember about the function, the stepwise function, how it looks like, so let me just show you how the graphs looks like. So simply means just this is your x and this is your fx. Okay, so it's saying that for all the values of x less than equal to 0, it is 1/4. So let's say here it is you have 1/4, and for x less than equal to 0. Okay, so it means that, sorry, x greater than equal to 0. So for x greater than equal to obviously what is this? Okay, less than equal to 0. So this particular thing means you have this this 1/4, and let's say at this point of time you have here it is x, and obviously like in discrete distribution you have particularly given value of x, so x is equal to 0, 1, 2. So it means that x is not defined for means this particular thing is not defined for any values after that. So it will be like here it's a 0, then you have 1 and 2. So like a graph I will show you in next time, because there is something involved. The most important thing is that if you just find this particular thing, you can actually uh, find mean also, variance also, for CDF also, you can actually draw its graph. So probability density function graph, we saw that you just like a bar graph with this type of chart, you can show that, and this particular CDF you can also show it by graph. So just let me know if you have confusion understanding CDF or mean, variance, and if you know if, and if it's given, if you calculate it or not. So let me know if you have any confusion. Hello. Okay, so did you understand mean and variance correctly? Hello guys, did you understand mean and variance? Okay, so I was asking that if you understand mean and variance correctly. So like there are a lot of questions to be practiced. Obviously, Gupta Kapil is the most important book you can opt for practicing those type of things. And generally, in the discrete distribution, you'll find a lot of problems related to throwing a dice or some other problem. And obviously, the simple thing is that just remember the properties of discrete random variable, how you calculate if it's a find k or some value a here that is missing, finding mean and okay. So what I can do? Okay, so I'm telling you just you can go to the Gupta Kapoor and you can solve some questions related on polarity distribution function.